Hello. So we're going to just take a little review um, of what the expectations are for the homework this week. What we want you to do is to calculate all of the possible indices for all of the possible combinations of the three woodlots that we've included in the scenario. So Browns Woods, North Campus Ravine, and the Dairy Bush. And we'll be using those sort of cartoon images as representation of the diversity and the population sizes of each of the species or each of the woodlots. So one of the ways that we can do this, and it may not be the best way, maybe you have another way, but one way that I would recommend is to create a bit of a table where you have each of the habitats, so Dairy Bush, North Campus, Ravine, and Browns Woods going along. And then each of the indices, the alpha diversity, the beta diversity, are actually, I would put, let's do the within habitat diversities first. So the Shannon diversity index here, like this. And then you want to do gamma, and you want to do beta, right? So gamma and beta are going to be a little bit different because you're going to have to sort of further subdivide. Here you're going to have Dairy Bush, North Campus Ravine, and Browns Woods. Like this, and then Dairy Bush, North Campus Ravine, and then Browns Woods. And of course, there's no difference here, so you're not going to fill out anything here or here. Similarly. Okay, and then I would start there and start to fill in all of these things. Now, the within habitat is pretty easy. It's just single numbers. Here, again, the single comparisons, but gamma can actually be compared across three or the different combinations. So I would also do a gamma calculation for all three here. So you don't have to, but all three gamma. You could certainly do that. So fill in this table as sort of a primary step. Then the next thing that I would do is I would start to ask myself how these things move together, whether or not, you know, Shannon diversity index is always high with high alpha or low with low alpha, whether alpha even affects the Shannon diversity index at all, and kind of try to figure all of that out and how it works. The other thing that I would do is really focus on the Shannon diversity index and the concept of evenness. Remember, evenness is a general concept. Shannon diversity index is a specific way of addressing evenness. So they are two separate things. But for each of them, what I would do is I would first calculate the diversity index for them as the data exist or are presented to you. But then I would play with it. So for example, if the alpha diversity of the Dairy Bush is 5, what would happen if I increased it to 10? And what would happen if all of those 10 were absolutely even? So there were 100 individuals of each, right? What would be the Shannon diversity index? And then play around with it. What happens if I have 10, but instead of totally even, I've got it completely uneven? Right? And see what the Shannon diversity index is here. How does that work? How does it play around? Do the same thing for fewer species too, and start to plot the Shannon diversity index to figure out how the Shannon diversity index moves and what actually limits it. What makes it higher? What makes it lower? And hopefully you'll learn that evenness actually plays a lesser role than something else. And figure out what that something else is, please. So be able to kind of understand and appreciate how these equations move, I think, is by far the most important thing. When is it good to use one? When is it good to use another? Why, for example, can we not use the Shannon Diversity Index to make a decision based on evenness between habitats? So kind of figure out all of that. But why it might be a really good tool to use if we're talking about changes in diversity or changes in evenness over time. So really try to understand how all of those things move and make sure that you come with your numbers for each of these when we see you next in class.